Good morning. I am Dr. Ramya Swetha. Today our topic is model analysis. Coming to the model analysis is based on the dimension analysis which we are understanding this model analysis. So it is very helpful for understanding these are some of the references which we consider for model analysis. So coming to the model analysis, it is the one of the fundamental analysis which is understood between the structures. So in two ways. So the first one, the way already constructed, like for example, irrigation structures. Some of the structures use construction structures. It's required some detailing understanding about that structure. So it was constructed earlier, so we don't know anything regarding that structure. So for that purpose, this model analysis help us a better understanding about that particular existing structure. So once we are scaling the structure, the original structure into some, we are scaling to something. So that is nothing but the model. So once we understand all these things in different all these things better gives the better understanding using this model analysis. The model analysis is purely based on the dimensional analysis. In earlier, we understand what is dimension analysis, which methods we are using for analyzing the dimension analysis, what are fundamental quantities, so what are the secondary or derivative quantities, how we are understanding all these and how we will get those dimensions, all these fundamental quantities as well as derived quantities. Based on that, now we are understanding this model analysis in better way. So coming to these are all the dimensions which we are going to derive from fundamental quantities. Fundamental quantities. So these are it may different in different ways. So coming to the model analysis, so in this there are several advantages are there. So the model tests are quite economical and convenient. So because the design, construction and operation of a model may be changed several times if necessary without increasing the much expenditure till most suitable design is we may update. So the first thing already constructed, for understanding that, and one more at the time of the design also, which kind of geometrical point of view, kinematical point of view, and dynamic point of view, we may understand which one is gives the better results as per the client requirement or as per the requirement of that particular project or construction work. So in which way it gives the better experience, So in that particular way, we may use this model analysis for understanding in different models. So for picking up which one is better one, so which gives the better performance, better construction values, whatever or it may reduce any environmental issues. So these are all the parameters, so which are relevant to that particular project. What are the parameters which are relevant to any particular project? We may consider the best model or best design using these kind of model analysis. So that is the one of the major advantage. It may reduce the expenditure and it reduce the operational cost, and an economical point of view it's very easy. And next one is with the use of models, performance of hydraulic structures or hydraulic machineries can be predicted in advance. So this is also one of the major advantage using the model analysis. So we may understand the performance of the structures. So how they are going to react in particular effect. So in such kind of things we may understand and we may predict all the values in advance using these kind of models. So this is the one of the major advantage we may understand. Once we understand and we are know about the performance of that particular construction or machineries, it's very easy once we predict that thing. So how it will affect, how to reduce the effects which are caused by those actions, so those reactions, and how to reduce the effects, and we may lose something. So how we will reduce, and which kind of parameters are helpful for us, and we how some parameters may increase or decrease. So which kind of parameters we may change, it gives the accurate one, so that gives the better idea about that particular things. So these are all happen using with the use of these models. And while designing a particular portion of the structure, if clear-cut analytical and reliable method is not available, then in such a cases, it becomes absolutely necessary to know about the safety and reliability of such parts, which is possible by means of model testing. So if we require any particular thing, a particular portion, particular thing of the structure, so the analytical and realitical method, there is not available. There is not available such kind of things. So in such cases, it becomes absolutely necessary to know about the safety and reliability of such parts, which is possible by means of the model testing. So we may understand this. Based on this model testing, we may understand the what are the things are going to be happened. And based on that, we may reduce the all such kind of effects which will happen by the unknown active based on those reactions. So such kind of it may helpful in this model testing. And one more advantage is model testing can be used to detect and rectify the defects and an existing structure without functioning properly. So these kind of advantages we may understand in our model analysis. So coming to the applications of the model testing, civil engineering structures such as dams, spills, weirs, canals, etc., and flood control, investigation of slitting and score in rivers, irrigation channels. Coming to the hydraulic machineries, especially turbines, pumps, centrifugal pumps, reciprocating pumps. So these are all we may understand using these model testing. So design of harbor, ships and submarines, aeroplanes, rockets and missiles. So tall buildings. So to predict the wind loads on buildings, the stability characteristics of building and airflow patterns in their respective things. So these are all in we may understand using this model application with less for safety purpose and reliability purpose as well as expenditure also. So using the less amount, we may understand all the such kind of parameters which may consider in that particular construction type or hydraulic machinery, hydraulic structure, whatever it may be. So we may understand all the applications using these model testing from hydraulic and hydraulic machineries and hydraulic structures point of view. Hydraulic machines and hydraulic structures. Hydraulic structure, hydraulic machineries and hydraulic structures. So like that, these are the some of the applications of the model testing. So coming to these model testing, these are the some of the applications. So we have to understanding the similarities. So in these, we may have three different types of similarities, three types. So comes under for which structure we are doing the model. So that structure is known as prototype. Prototype. It is like it's a original structure. So we are using these models. So coming to these So in these three types of different similarities, the one is the geometric similarity, the second one is the kinematic similarity, and the next one is the dynamic similarity. Coming to the geometric similarity, the model must be the same shape as the prototype. So each dimension should be scaled by the same factor. So the dimensions in length, breadth, depth, thickness. So like all these type of, this is thickness or depth, breadth or width, length. So all these are scaled by the same factor. For geometrical similarity, 1 is to 100, 1 is to 10. So we are considering 100 meters of prototype into 1 meter of model, like that. This is the example. Like this we are understanding the geometric similarities. Oh, it is depends upon the model must be the same shape as prototype. The prototype is nothing but the for which original structure, for the original structure we are considering some factors, some scale ratio we are considering. So we are preparing these models. Those are models. And so like this, we may understand such types of similarities are known as geometric similarities. So based on the dimensions. So length, breadth, depth, like this. Coming to the kinematic similarities, based on the kinematic, so velocity at any point in the model must be proportional. So that's why here, these are all comes under fundamental. So next one is geometric, area, so volume. So like these such types of parameters we are going to scale ratio. Such types of similarities is known as geometric similarities. So similarly kinematic. So these are all comes under kinematic similarities. Next one is the dynamic. So these are all comes under, these are the some of the parameters which are all comes under dynamic quantity. So geometric, kinematic, and coming to the dynamic similarities, all forces in the model are scaled by the constant factor to corresponding forces into the prototype flow. So this is called dynamic similarities. So like this, first we are considering these similarities. So geometric similarity, kinematic similarity, dynamic similarity in dimensional point of view, and comes under velocity, like that, some of the parameters which are comes under kinematic characteristics. So such similarities. And next one is the dynamic. Best example is force. So based on the dynamic properties point of view, those similarities we are considering for prototype and model. And it is comes under for constant factor to the corresponding flows in prototype, and for coming to the scaled by the same factor, that is comes under geometric. So these are all comes under similarities. Now important, coming to the model analysis, forces influencing hydraulic phenomena are the playing a major flow characteristics in these. So in these, forces are plays a major role. So we have different types of forces, that is various different types of forces are there. Some of them we are understanding here. The one is inertia force. So inertia force is denoted by F with respect to the I suffix. In suffix I, that is inertia force. It always exists in fluid flow problem. It is equal to the product of mass and acceleration of the fluid and acts in the direction opposite to the direction of the acceleration. So the fluid flow acts in the direction opposite to the direction of acceleration. It always exists in fluid flow problem. It is customary to find out the force ratios with respect to the inertia forces. The next one is the viscous force. Viscous force. It is present in the fluid flow problems where viscosity is to play an important role. It is existing in any fluid flow problem. Coming to these viscous force, it includes to viscosity. Whenever viscosity is to play important role, this force is going to involve. It is equal to the product of shear stress due to viscosity and surface area of the flow. So shear stress due to viscosity and surface area of the flow. That such type of force is known as viscous force. Gravity force. It is present in case of open surface flow. It is equal to the product of mass and acceleration due to gravity. So this is denoted by G in suffix force F. F with respect to G in suffix. It is present in open surface flows and it is equal to the product of mass and acceleration due to gravity. The next one is pressure force. Pressure force. Pressure force, the suffix is P. So this types of flow is present in case of pipe flow. Pipe flow. It is equal to the product of pressure intensity and cross-sectional area of the flowing fluid. Pressure intensity and cross-sectional area of the flowing fluid. So this is known as pressure force. Next one is the surface tension force. So coming to the surface tension force, it is equal to the product of surface tension and length of the surface of the flowing fluid. So it is equal to the product of surface tension and length of the surface flowing fluid. So it is denoted F suffix S. The next one is the elastic force. It is equal to the product of elastic stress and area of the flowing fluid. So these are the 6 different forces which plays a vital role in model analysis. So coming to these 6 forces. So based on these 6 forces, different 5 dimensionless numbers are occurred. Reynolds number, Froude number, Euler's number, Weber's number, Mach number. So these are the 5 different dimension numbers are occurred due to these 6 forces. So based on these 6 forces, inertia force, viscous force, gravity force, pressure force, surface tension force and elastic force. In all these, inertia force is the common factor. So based on the inertia force, all these are occurring. So inertia F of I in every dimensionless number. Inertia versus viscous. Inertia versus viscous forces occurring in fluid system. So this Reynolds number signifies the relative prominence of the inertia to the viscous force occurring in fluid systems. This number is taken as the criterion of dynamic similarity in the flow situations where the viscous forces predominate, examples being motion of the submarine completely underwater, that is the one, and low velocity motion around automobiles and aeroplanes, incompressible flow through pipes of smaller sizes, flow through low speed turbo machineries. So this is Reynolds number. Based on that Reynolds number, we are understanding the Reynolds model law. So Reynolds model is equal to Reynolds number of prototype. Such law is known as Model's law. In this, inertia force and viscous force plays a vital role. Inertia force and viscous force. So Reynolds number. Inertia and viscous force, Reynolds number is equal to Reynolds number model is equal to Reynolds number prototype. This is the one of the dimensionless number which is based on the inertia and viscous force. The next one is the Froude number. Froude number in these inertia force to gravitational force based on inertia force and gravitational force. These two, inertia and viscous, is Reynolds number. Inertia and gravitational force is Froude number. Froude number governs the dynamic similarity of the flow situations where gravitational force is most significant and all other forces are completely negligible. For examples, flow over notches and weirs, flow over spillway of dam, flow through open channels, considering waves and jumps, motion of the ship in rough and turbulent sea. So these are the significant factors. So based on these, Froude law is occurring, Froude model law. So that Froude model law is Froude number model dimensionless number is equal to Froude number prototype. Next one is the Euler's number. So in this Euler's number, pressure. So inertia versus pressure. Inertia force is the common to the all the parameters. Inertia force to pressure force, that is Euler's number. The Euler number is important in flow situations in which a pressure gradient exists. So example, discharge through orifices, mouthpieces and slices. And the next one is pressure rise due to the sudden closure of valves, flow through pipes and water hammer created in penstone. So this is the significant, most important in Euler's number. The next one is the Weber's number. So the Weber's number, this number assume important to the following situation: capillary movement of water in soils, flow and liquid atomization. So this is for Weber's law, and this is the Mach number. It is important in compressible fluid flows at high velocities. So this is comes under Mach number. So based on this, so this is the aspects which we have to consider. So Reynolds number, inertia is the common factor for any force. So inertia to viscous is Reynolds number, and it is laminar viscous flow is confined passages where viscous effects are significant. We are using this kind of Reynolds number or dimensional number. These are all the dimensionless numbers. So laminar viscous flow in confined passage. So where viscous effects are significant, we are using this Reynolds number. Inertia is the common factor. Inertia versus viscous is Reynolds. So this is the rho VL model is equal to rho VL by mu prototype. Like this we may write rho VL mu model all mm model is equal to rho VL prototype. Like this we may address this model law. So after that, these are the dimensionless numbers, the same as model laws also. So next one is the Froude number. Coming to the Froude number, inertia to gravity force. Inertia to gravity force. In this, free surface flows gravity effects are important. Where gravity effects are important, that to free surface flows we are using this Froude number. This is the formula. Inertia to gravity. Inertia to viscous is Reynolds number. Inertia to gravity is Froude number. The next one is inertia to pressure. Inertia to pressure is Euler's number. This is V by rho, P by rho, V by root of P by rho. The next one is Weber's number. It is inertia to surface tension. Inertia to surface tension. It comes under small, this Euler's number for pipe flow, conduct flow where pressure variations are significant. Where pressure variations are significant, we are using this Euler's number. So next, coming to the inertia force to surface tension flow, surface tension, such type of dimensionless number is Weber's number. So small surface waves, capillary and sheet flows where surface tension is important. Where surface tension is significant, we are using this Weber's number. The next one is the Mach number. So inertia to elastic force. So inertia to viscous is Reynolds, inertia to gravity is Froude, inertia to pressure is Euler's, inertia force to surface tension force is Weber's number, inertia force to elastic force is Mach's number. So Mach number. So it is for high speed flow where compressibility effects are significant. Such type situation we are using this Mach's dimensionless number. These are all dimensionless numbers. So like this we are understanding this dimensionless group. And next we are as similar these model laws also, Reynolds model law, Froude model law, Euler's model law, Weber's law, Mach's model law as like these model laws. So like this we are understanding these laws. Reynolds number model versus is equal to Reynolds number prototype. This is the Reynolds model law, and Froude model is equal to prototype, like Euler's, Weber's and Mach numbers also we are getting the model laws. These are all dimensionless numbers as well as model laws also the same. Reynolds model law, Froude model law, Euler's model law, Weber's models and Mach's models. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.